Everyone, in this video we are going to be reviewing for our end of course test, and we're going to be covering solving equations and solving literal equations. The cool thing about this topic is you guys have been doing this for years, and we just continue to build on it as you get into Algebra 1. So hopefully a lot of this not only will feel like review because we've done it in our class, but also because you've done it in previous math classes. So first, I just wanted to review with everyone the inverse operations. So when you see this word inverse, you might think of the opposite. So we're trying to come up with the opposite operation or the inverse operation, basically to like undo something. And undoing operations helps us solve for a missing variable. So the opposite or the inverse of addition is subtraction. And I know, so you've been doing most of these for many years. Subtraction, the inverse is addition. The inverse of multiplication is division, and vice versa, right? Now the ones here on the bottom are kind of the ones that we've learned more recently, right? The inverse of square rooting is squaring. So I can write that. But then I can also show you if you have a square root, to get rid of that square root, you square it. They are inverses of each other. And so whatever is under here, when you do that, you'll end up with just whatever's underneath. Those are inverses. Same thing with cube root. You will be cubing. So if you have the cube root of something, in order to get rid of that root bar, you just cube it. And lastly, the fraction. So sometimes we might think of reciprocal, but that's really not the inverse of a fraction. So what I wanted to show you guys here, just remind you here, here's just an example. If you have something like this, what we can do is cross multiply to solve for x. So when we see fractions on both sides, we oftentimes think of cross multiplication. And really, when you're cross multiplying, all you're doing is you're multiplying both sides by the opposite denominator, so to speak. Cross multiplication is just an easier way to remember that. So don't forget, as we're going through all these slides, you guys can pause at any time. I actually recommend it. I'm asking you to because this is your practice time. So you want to make sure that you're using it to your advantage and using it wisely. Going through a few examples with me is great, and then pausing and trying on your own, so that way you can come back and check the answer. So here's our first example. You can see there's not a single number on the board, and a lot of times that's what people equate algebra with, is just letters. It tells us the perimeter of a triangle is given by this formula, and it wants us to solve for b. So they want us to get b all by itself. So these are what you hear of as literal equations. It's like its own separate topic in our class, because you're not going to end up with a number as an answer. All we're doing is rearranging the equation. We're going to use all of those inverse operations that we just reviewed to sort of manipulate the pieces, move them around, and get what we want alone. Right now, P is by itself, but we want B by itself. So all we have to do is move everything else over. So move this A over and move this C over. And to move things, that's when we use the inverse operations. So we have to identify what operation is happening first to be able to tell, well, what's the opposite of it? And these three are all being added together. So remember, the inverse of adding is subtracting. So we're going to subtract A from both sides. And all you're going to have is P minus A. You can't combine those. Those are not like terms, so you just write them next to each other. And then we'll have plus C. Now we're trying to move the C over, so we'll subtract C from both sides. And you end up with P minus A minus C. Now, it's okay that our B is on the right-hand side. You could always just rewrite it, right? And so we find that P minus A minus C is B. All these letters. So the whole deal with literal equations is you're just moving things around and rearranging those letters. All right, this one says solve for x. So we're going to get an actual number answer. And some test taking tips too as we're going through this. Whenever you're given a multiple choice question and they want you to solve for a single value, there's actually two ways to solve these. We can solve this for x, which we will, or technically you could take each of these values and plug it into the equation and see which one works. I know I have a favorite method. I personally would just solve it, but knowing that that's a technique could be helpful and could be powerful. If you come to test day and you feel stuck and you're just not quite sure where to start, that could be a place to start, is kind of get your bearings and try it. Take the A value and plug it in for X everywhere you see an X. And if it's the answer, then it's got to make sense. The left side must equal the right side. But let's go ahead and solve this the old school way, I guess, in this case. We want to use Pemdas, or you may have heard it as GEMDAS, right? Our parentheses or grouping symbols. So we're going to do those first. And so when you look at the parentheses inside here, you can't combine those. So, all right, we're going to move on. There's no exponents to deal with, so we'll do our multiplication. So we have to first distribute. This 1/2 is in front of the parentheses, so we're going to multiply everything on the inside by that negative 1/2, because that's x over 2 minus 1/2. So negative 1/2 times 2, and then negative 1/2 times negative x. And then we can keep distributing. 3 times 4 minus 3 times 5x. I'm just writing it all out so you guys can see it. Now let's simplify this a little bit. 1/2 times 2, that's just 1. Here we have a negative times a negative, that's a positive 1/2 x. 3 times 4 is 12. 3 times 5 is 15, minus 1. All right, so what we want to do, we do have variables on both sides. So before we start moving things, let's go ahead and combine like terms. So on the left-hand side, we have two terms that are x terms. We want to combine 1/2 x plus 1/2 x. Oh, that's nice. 1/2 plus 1/2 is 1. Right? And these do look a little different. So here I wrote the 1/2 in front of the x, and here the 1/2 is sort of combined, but these actually mean the same exact thing. I want you guys to know that. All we did was sort of pull that one off, the 1/2 off of the x, but these mean the same thing. We'll bring down our minus 1, and then negative 15 minus 1 is negative 16x. There we go. Now our goal in all of these is to get x by itself. So we've got to first get all the x's together, right? So if there's an x over here on the left, let's bring the 16 over. It's kind of up to you which side you want to get the x's on, but I just tend to go for the left. I don't know why. We usually see x equals, but it will work either way. All right, our next step is to continue getting x by itself. So let's move the negative 1 over by doing the opposite, by adding. And we're left with 17x equals 13. Now at the last step, this is 17 times x. So remember that inverse chart we filled out, the inverse of multiplication is division. Here we go, x equals 13 over 17. It is C. So if you made your way down to C and you plugged this in everywhere you saw an X, then you would have the left-hand side equaling the right-hand side. And so that is the solution. So there's two ways to solve that one. All right, here's a fill in the blank. solve the equation. So our goal is always to get x by itself. This one might feel easy compared to that last one, huh? we're gonna hold on tight to this for a minute. We want to get rid of everything else first. So subtract 2 from both sides and get 65. Oops, I forgot my x. There we go. Now we're down to -5 times x. Remember, the inverse of multiplication is division. And x is 12, right? -12. I had to think about that for a minute. Let me just double check that. I don't have my calculator. I don't think it's 12. Nope, it's 13. I'm glad I just double checked because I was doing that in my head rather quickly. Let's double check 13. And you guys, there we go. You guys will have calculators. So definitely use them to your advantage. You know, quickly do that. 65 divided by -5. You'll get -13. And also don't forget that in any of these, you can always go back and check your work. That's one of the other really cool things about solving equations, is you can make sure you got the right answer. So if we plug in that x value, then, like I said earlier, it has to work. So -5 times 13 is -65 plus 2 equals 67. So you can see that there's something wrong here because, oh, here's what's wrong. I didn't plug in a negative. It's a -13, so this would make it a positive. There we go. But it's all good in checking. Like, every single step that we've done is worth it. To be like, oh, wait, that wasn't going to work. Did I plug it in right? Did I make a mistake? It's always a good idea to check your work. All right, here's another literal equation because again, they're not asking for like a single value for the answer. They're just trying to rearrange the equation. It says solve for W. So right away, we can see that we can cross off A, right? Because that's 2W. So that's not solved for W. So we already have a 75% chance of getting it right. So our goal is to get the W term by itself. So again, hold on tight. Don't move that. Move everything else first. So minus 2L, minus 2L. We're just rewriting sort of on the other side. Now this is multiplication, so the inverse is division. There we go. P minus 2L over 2. That is C. Next example, what is the value of x in the equation below? So these are all either solving for x or a literal equation. So they want us to solve here for x, and we have some parentheses going on. Whenever you see parentheses, you should think distribute. So let me grab a different color. So we're going to distribute the 2 to everything on the inside. 2 times 10x plus 2 times 8 minus 1. And then the same thing with the 5. 5 times x minus 5 times 6. Or you could have written it as plus 5 times -6. Either way. All right, let's do this math. 2 times 10 is 20. 2 times 8 is 16. 5 times 6 is 30. Now let's combine any like terms that we can on the same side first. So 16 minus 1 is 15. And then our next step is going to be combining like terms on the opposite sides. So I'm going to get all the x's together. I did minus 5x because that's the opposite of plus 5x. So 15x plus 15 equals -30. And we'll subtract 15. 15x equals -45. So let me come over here. And this is multiplication, so remember the inverse of that is division. X equals -3. So let's just check our work. Let's plug in -3 everywhere we saw an X. This is also really good practice for order of operations and simplifying. All right, so we have -30 plus 8 there on the inside and -9. -30 plus 8 is -22. 5 times -9 is -45. We're almost done on the left-hand side. 2 times -22 is -44. Ooh, this is looking good. And then -44 minus 1 is -45, which does equal -45. So we did the problem correctly. Nice work. All right, here's an example where we have two fractions, and we talked about this earlier with the inverse chart. When you have two fractions, you can cross multiply. So 6 times 4p minus 8, and then 3 times 6p plus 4. If you wanted to, like if you forgot that method, look, oops, okay. We know that we're dividing by 3 on this side, right? And the inverse of division is multiplication. So you could multiply both sides by 3. And that's what we're doing, right? Look what happens. 3 times 6p plus 4. That's what we're doing here. And then you would just simplify that and you would end up multiplying that side by 6. So multiplying is basically just a shortcut method of doing 2 steps in one, essentially. So we're going to distribute that 6, get 24p, and then 6 times 8, 48. Distribute our 3, 18p, and 12. Now the goals remain the same, right? Get all the p's together, all the numbers together, and then get p alone. So we'll subtract 18p from both sides. We have 6p minus 48 equals 12. So we're going to get the p term by itself, so we'll move the 48 over first. I'm going to come over here. And lastly, we'll divide both sides by 6. There we go. And we could take that 10, plug it in, and both sides should be the same. Now let me move this guy a little bit so I have more space. Not sure why it's so low. Okay, so this one is similar in that we have two fractions, so we can do the same thing. We can cross multiply. Let me grab my pen tools being nutty. Okay, so it's going to be 2 times the whole thing, all of it, not just the parentheses, and then 6 times the whole thing. So when we're dealing with simplifying these things, you do want to keep PEMDAS or GEMDAS in mind. So we're going to do this inside parentheses first. 9 times x, and then 9 times -4. There we go. And then 6 times x, and 6 times 2. Perfect. Now we can distribute this 2. 2 times 9, and 2 times -36. There we go. Now we're kind of always coming down to the same step here. So we're going to get all the like terms together on the same sides. 12x, and then, ooh, let's do this. It's plus 72, plus 72, 84. Bring this over here. And our last step is to divide both sides by 12. Do you know that I actually never memorized my 12s? Who was my math teacher? I mean, I know a few of them, but not as many get higher. But yeah, this is 7. All right, here we go. Here's an SOL type question. To find the volume of a pyramid, you use this formula. Which equation solves for B? So we want to get big B by itself. So we're going to leave the B alone and move everything else. So it's kind of up to you if you want to start with the H or the 1/3. I don't know, I'm seeing the H first. So it's times H. So we're going to divide both sides by H. Remember, the opposite of multiplication is division. There we go. Now to get rid of this 3, this is essentially your dividing, right? We could rewrite this as b over 3. It's the same thing. So the inverse of division is multiplication. So let's multiply both sides by 3. These will cancel. That's the whole goal. And you get 3 times v over h. Let's match it up. So over h, so it's definitely not b, it's definitely not c, because the 3 is on top. If the 3 were on the bottom, then it would have to be 1/3. That's not what we have. We have 3. So it is A. All right, here's our last one. We're going to get A by itself. These are those literal equations. And you know what? I just noticed that this is sort of, what's the right word? Transitioning into our factoring unit. So this is not a question necessarily that I would have put in this particular set of questions, but let's do it together. You'll see ones like this when we get to reviewing our factoring problems. We want to get A all by itself. And if you look at this, there are 2 terms that have A in it, but they're not like terms, right? 3A and 5AC, but they both share an A. So whenever something is shared, you can always factor it out. Remember we talked about the GCF is the greatest thing that they share. So look at what we can factor out of each of these terms. We can factor out an A. And then what's left? Well, if we take an A from the first term, there's a 3 left. And if we take an A from the second term, there's just a 5 and a C. If you don't believe me that you're allowed to do this, you can always go in reverse and distribute this A and see what happens. And you'll get right back to this. A times 3 is 3A. A times 5C is 5AC. So look, now we have A times all of this. This is all one unit. And this whole unit is being multiplied by A. So what's the inverse of multiplication? Division. We can multiply by the entire thing because it is one unit. There we go. That's it. A equals Q over 3 plus 5C. And again, we'll do more of these when we get to reviewing factoring. Don't forget that you guys can always find previous notes, previous recordings, and extra help on any topic that we've covered this year in your end of course tracker. So this video actually corresponds to this date. So you're going to see those notes and that link populated in there for you guys. As always, if you need anything, please don't hesitate to reach out. Bye, everybody.